Hello dear student, this is Mr. Hitesh Patel, Assistant Professor LJ Institute of Engineering and Technology. Today in this video session we are going to discuss some basic concepts of basic mechanical engineering. In this video session we are going to solve some basic numericals of chapter number 3 properties of gas. In last video session we have solved 3 numericals. Okay. Today in this video session we will solve more numericals related to gas. So let's start. The first numerical is 1 kilogram of gas at a pressure of 100 kilopascal and temperature of 17 degrees Celsius is compressed isothermally in a piston cylinder arrangement to final pressure of 2500 kilopascal. The characteristic gas equation is given by the relation PV is equal to 260 T per kilogram, where T is in Kelvin. Find out final volume, compression ratio, change in enthalpy and work done on the gas. Okay. So here 1 kilogram of gas, that means mass of the gas is 1 kilogram. The pressure is 100 kilopascal, that is P1. Temperature is 17 degrees Celsius. Okay. And final pressure is 2500 kilopascal. Here you can see that the temperature is 17 degrees Celsius is compressed isothermally. That means this process is isothermal process. That means T1 is equal to T2 is equal to 290 Kelvin, because 17 degrees Celsius is, if we convert into Kelvin, then we get 290 Kelvin. And here they have given us relation PV is equal to 260 T per kg. That means by equation PV is equal to MRT, mass is 1 kg, so value of R will be 260. Okay. So we need to find out is final volume, that is V2, compression ratio, that is R, change in enthalpy, that is delta H, and work done on the gas, that is W. Okay. So we know that the relation, standard relation, that is P2 V2 is equal to 260 T. By putting the value in this equation we get the value of V2. So P2 is 2500, V2 is that we need to find out 260, and the temperature is 290. We get the value of V2 as 0.03016 meter cube. Now we need to find out the value of R, and we know that the R is a compression ratio, that is V1 by V2. So we need to find out the value of V1. So for finding the value of V1 we are putting the equation as P1 V1 is equal to 260 T, and we get the value by putting the value of pressure P1, that is 100 into 10 raised to 3, and 260, and the temperature is 290. We get volume V1 as 0.754 meter cube. By putting this value we get compression ratio R as 0.754, that is the value of V1, divided by V2, that is 0.03016. We get compression ratio R as 25. Now next we need to find out that is change in enthalpy, that is 0, that we already knew that delta H is equal to m Cp T2 minus T1, and we know that for isothermal process temperature T1 is equal to T2, and by putting this value in this equation we get delta H is equal to 0. Now next, that is work done during the process, that is P1 V1 log V2 by V1 base E. We know the value of P1 and V1, that is 260 T, value of V2 that is 1, and value of V1 that is 25. Or we know the ratio of V2 by V1, that is 1 by 25, because V1 by V2 is equal to 25, then V2 by V1 that is 1 by 25. By putting the value of V2 by V1's ratio we get the answer, that is minus 242.70 kilojoule. Here work done is negative, and negative sign indicates that work is done on the system during the process. Okay. So that is all about the numerical. The next numerical is determine the work done in compressing 1 kilogram of air. Here the mass of the air is 1 kilogram from a volume of 0.15 meter cube, that is volume V1 is equal to 0.15 meter cube at a pressure of 1 bar. P1 is equal to 1 bar. to a volume of 0.05 meter cube, means volume V2 is equal to 0.05 meter cube when the compression is isothermal and adiabatic. Here take gamma is equal to 1.4. In this numerical, for solving this numerical, we need to find out the work done during isothermal process and work done during adiabatic process. So the simple equation that we know that the work done during isothermal process, that is P1 V1 log V2 by V1 base E, and adiabatic process, that is P1 V1 minus P2 V2 upon gamma minus 1. Okay, so let's start with the isothermal process. First of all, work done W is equal to P1 V1 log V2 by V1 base E. We have value of P1, V1, V2 and V1. Simply by putting all the value in this equation, we can easily get the value of the work done during isothermal process. So P1 is 1 bar, okay, and into 10 raised to 2, volume V1 that is 0.15, okay, V2 that is 0.05 and V1 that is 0.15. By putting value, we get work done W is equal to minus 16.47 kilojoule. Here work done is negative, and negative sign indicates that work is done on the system during the process. Now let's start with the case 2. For case 2, we need to find out the work done during adiabatic process, and the simple equation for adiabatic process, that is P1 V1 minus P2 V2 divided by gamma minus 1. But here we don't have the value of P2. For finding the value of P2, we have one equation, that is PV raised to gamma is equal to C. So for process for state 1 and 2, we can rewrite this equation as P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So P2 is equal to P1 and V2 by V1, P2 is equal to P1 into V1 by V2 raised to gamma. So we get P2 is equal to 4.65 into 10 raised to 2 kilo Pascal. By putting the value of P2 in equation P1 V1 minus P2 V2 divided by gamma minus 1, we get the pressure P1 as 10 raised to 2, V1 as 0.15, P2 as 4.65 into 10 raised to 2, and V2 is 0.05 divided by gamma minus 1, that is 1.4 minus 1. So the answer will be 0.4. So final answer for the work done during adiabatic process is minus 20.62 kilojoule. Here work done is negative, and negative sign indicates that work is done on the system during the process. Next numerical is 0.67 kilogram of gas at 14 bar and 290 degrees Celsius. Here mass of the gas is 0.67 kilogram, pressure is 14 bar, and the temperature is 290 degrees Celsius. So by converting it into Kelvin, we get 563 Kelvin. Is expanded to 4 times the original volume according to the law PV raised to 1.3 is equal to constant. Here the gas is expanded to 4 times its initial volume. That means V2 is equal to 4 times V1. Okay, and it follows the law PV is raised to 1.3 is equal to constant. Here PV raised to 1.3, that is the value of N, that is polytropic index. So here they have given us N is equal to 1.3, and we need to find out the original and final volume of the gas, that is V1 and V2. Okay, final temperature of the gas, that is T2, final pressure of the gas, that is P2, and take R is equal to 287 joule per kilogram Kelvin. So dear students, we need to find out first of all the original and final volume, that is V1 and V2. Okay, we already have one condition, that V2 is equal to 4 times V1. So if we find V1, then we can easily calculate V2. So the standard equation, that is P1 V1 is equal to MRT1. By putting all the value in this equation, we get initial volume V1. So P1 is equal to 14 into 10 raised to 2 into V1, that we need to find out, mass that is 0.67, R 0.287, and T1 is equal to 563. By simply calculation, we get the value of V1 as 0.07732 meter cube. Okay, well, now we know that the final volume is 4 times its initial volume. That means V2 is equal to 4 times V1. So by putting the value of V1 in this equation, we get 0.3092 meter cube, that is the value of V2. So we get the original and final volume. Now next is the final temperature of the gas. Okay, so we need to find out T2. They have in this numerical they have given us the value of T1, but we need to find out T2. Okay, so for finding out T2, we have a relation between temperature and volume. So first of all, let me remind you one equation, that is the relation between pressure, volume and temperature during polytropic process. T1 by T2 is equal to V2 by V1 raised to n minus 1 is equal to P1 by P2 raised to n minus 1 upon n. Now we have the value of T1, V1 and V2. So from this equation we can easily calculate the value of T2. So by putting all the value, we get T2 as 371.44 Kelvin. Okay. Now we need to find out the pressure P2, final pressure. So we know the law of polytropic process, that is PV raised to N is equal to C. We know that the initial state is 1 and final state is 2. Then we can rewrite this equation as P1 V1 raised to N is equal to P2 V2 raised to N. So we get P2 is equal to P1 into V1 by V2 raised to N. By putting all the values in this equation, we get P2 as 2.316. So this is all about the polytropic process numericals and adiabatic process numericals. So if you have any queries regarding to this, then you can write down your comment in the comment section. Thank you for watching my video.